In this module, we are going to learn Levhari, Patinkin and Johnson growth model. Recently, most of the economic theorists have realized that money has an important role to play in real growth models. For this purpose, the monetary growth models were introduced, which shed some light on the matters of monetary policy in modern growing economies. The monetary growth theories have large overlapping dual role. First, to construct a theoretical framework which would allow for a meaningful integration of monetary theory and real growth theory. And second, to provide meaningful suggestions on questions of monetary policy. D. Levhari and D. Patinkin in 1968 and H. G. Johnson in 1962 objected to Tobin's model on the basis of the fact that it treats money solely as a store of value and, in effect, ignores the services it performs in overcoming transaction cost, etc. In the work of Levhari and Patinkin, it has been argued that the existence of cash balances in an economy facilitates production. Levhari and Patinkin hold the view that money is held only because it enables the economic unit in question to acquire or produce a larger quantity of commodities in the usual sense of the term. They discussed money as a producer good and as a consumer good. And it can also play both these roles simultaneously. On the other hand, Johnson has indicated the strengths and weaknesses of the classical, Keynesian and post-Keynesian versions of money demand and their impacts on output and income.
After studying this module, you shall be able to examine the role of money as consumer good as proposed by Levhari and Patinkin. Examine the role of money as producer good as proposed by Levhari and Patinkin. Understand the Johnson's view on demand for money. Examine basic controversies of the Keynesian model. Let us begin this model with the discussion of Levhari and Patinkin model. David Levhari and Don Patinkin in 1968 introduced a model of economic growth in which money is treated as consumer good. They demonstrated that if the aggregate price level changes at a constant rate and the demand for real balances with respect to the money rate of interest is inelastic, then the balanced growth path is also stable. The model consists of the following equations. Production is function of labor and capital, that is y is equal to fkl, which is equal to L into Fk. F dash k is greater than 0, F double dash k is less than 0, and limit k tends to 0, F dash k is equal to infinity, and limit k tends to infinity, F dash k is equal to 0. It is homogeneous of degree 1 in capital K and labor L and has the usual neoclassical properties. The per capita output, that is Y upon L, can therefore be expressed as a function of capital labor ratio K, and labor supply grows at a constant rate N, and K is equal to capital K upon L. Saving S is a constant fraction of disposable income. The assumption of constancy of saving rate can be related with nominal money supply, which grows at the rate mu, and P is the price level which changes at the rate phi. The real rate of return on capital R is the marginal product of capital, that is F dash K. If we do not take into account the utility yield of holding money balances, then the saving function is capital S is equal to S y plus m upon p multiplied with mu plus r. Disposable income is obtained by the output Y plus the real value of government transfer payments, that is mu into m upon p, less the loss in real value of existing cash balances due to inflation, that is pi into m upon p, plus the opportunity cost of holding money, which is r plus pi into m upon p. Not all of the savings go into investment. The rate of change of real balances, that is m upon p multiplied with mu minus pi, cannot be held in the form of physical assets. Hence, under the conditions of equilibrium in capital market, I, the investment function, and can be defined as I is equal to S minus m upon p multiplied with mu minus pi. Dk is equal to k hat is equal to I minus delta k, or R is equal to f dash k. dl upon L is equal to L hat upon L is equal to N. M upon Pk is equal to M is equal to lambda I Fk upon K. I is equal to R plus pi. dm upon M is equal to M hat upon M is equal to mu. dp upon P is equal to P hat upon P is equal to pi is equal to mu minus n minus M hat upon M. Total consumption is now represented by 1 minus S multiplied by FKL plus M upon P mu plus R, but according to Levhari and Patinkin, in order to obtain equality of savings and investment, we need to deduct from total output not the total consumption expenditure but the physical consumption. Hence, the change in capital stock is K hat is equal to FKL minus 1 minus S multiplied with FKL plus M upon P mu plus R minus M upon P R plus pi. It is further assumed that the price level instantaneously adjusts itself so as to equate the demand and supply for real balances. That is, MD upon P is equal to lambda FKL is equal to M upon P. The desired level of physical consumption, Cp, should be represented by Cp is equal to 1 minus S multiplied with Fkl plus M upon P mu plus R minus Md upon P multiplied with R plus pi. Thus, the disposable income, which determines the desired total consumption, the relevant quantities are the volume of the transfer payments actually received by individuals, that is mu into m upon p, and the imputed income for real balances actually held, that is r into m upon p. Individuals always try to achieve the desired balance in their real balances, which they consider to be convertible into physical capital at R rate of return. On the other hand, the desired level of consumption is determined by the amount of liquidity services which individuals have. The real balance effect be derived by Cp is equal to 1 minus S multiplied with Fkl plus M upon P mu plus R minus Md divided by P multiplied with R plus pi. Differentiating it partially with respect to M upon P, we have the derivative of Cp with respect to M upon P is equal to mu plus R. Levhari and Patinkin have argued that any rationale for holding money is actually to use it to purchase the consumer goods or producers goods. If money is treated as consumer goods, then it means that people derive utility from money holdings as money provides protection against uncertainties. However, there is some opportunity cost of holding money, which is expressed in terms of nominal rate of interest I, which is equal to real rate of return R plus the rate of inflation pi. The demand for real balances can be written as MD divided by PL, which is equal to H, I and Y, and HI is less than 0 and HY is greater than 0. This indicates that demand for real balances is negatively associated with nominal rate of interest and positively associated with the level of output. Other things remaining the same, if the rate of return on capital and or rate of inflation increases, the demand for real balances falls. Since money supply is growing at rate mu, total money supply in the economy consists of MTS is equal to M0 exponential of mu t. Thus, the expected cost of holding money balances is equal to R plus mu minus n minus m hat upon m. Here, the rate of inflation is equal to mu minus n minus m hat upon m. The symbols MD and MS are equal to MD upon PL and MS upon PL respectively. It is assumed that money market is in equilibrium and MD is equal to MS. Further, it is also assumed that it is the price level that brings this equality. The excess demand in the commodity market is equal to the gap between planned investment and planned savings in goods. That is, I upon L minus S upon L plus omega MD minus MS is equal to 0, where omega is the adjustment factor and assume that the excess demand for asset flows is a constant proportion to excess demand for asset stocks and the planned investments are assumed to be equal to the planned savings. But the change in capital stock is the difference between availability of capital and rate of change of real balances, that is M upon P multiplied with mu minus pi. K hat is equal to S minus M upon P multiplied with mu minus pi, and K hat upon L is equal to K hat plus Nk. Using all these functional relationships, the investment function becomes K hat upon K is equal to phi k minus n. This can also be termed as the dynamic path of capital intensity. Phi k is equal to sfk upon k minus 1 minus s into n into m upon k plus si into m upon k. For steady state equilibrium, phi dash k is equal to sk f dash k minus fk divided by k square minus 1 minus s into n minus si multiplied with dmk upon dk plus sm upon k into di upon dk, where 1 minus s into n minus si is greater than 0. Increase in capital stock has an uncertain effect on excess demand for capital but may either increase or decrease savings since the income and wealth effects on savings work in opposite directions. If the system is near the golden rule, then the second term is positive, but the first and the last terms are unambiguously negative. Assuming the steady state path, The effective labor supply and the nominal quantity of money grow respectively at the constant rates that are n and nu, where the former is always positive but the latter can be negative. From constancy of capital labor ratio, it follows that small k hat upon k is equal to capital K hat upon k minus L hat upon L is equal to capital K hat upon k minus n is equal to 0. In this system, the real value of per capita physical capital denoted as small m is equal to capital M upon PL is also assumed to be constant, that is small m hat upon m is equal to capital M hat upon m minus p hat upon p minus L hat upon L is equal to mu minus pi minus n, which is equal to 0. Thus, total physical capital and total real money balances both expand at n. Now it is important to find the steady state value of k. This can be found using earlier equations. We obtain fkl upon k multiplied with lambda n minus s, which is multiplied with 1 plus lambda into n plus pi plus r. And this component is added with n, which is equal to 0. Using earlier equations, we get fk into s into 1 plus lambda into n plus pi plus r minus lambda n is equal to nk. The distinguishing feature of a market economy is that not all the savings need to be devoted to augmenting the capital stock. Some of it can also be used for maintaining the real balances. The savings devoted to physical capital are SP is equal to S minus the derivative of M upon P with respect to T. But this function of physical savings can also be written as SP is equal to Y minus CP. Hence, the SP is equal to S minus derivative of M upon P with respect to T can be rewritten as SP is equal to S multiplied with Y plus M upon P mu plus R minus M upon P into mu minus R. In the steady state, it becomes SP is equal to S into Y multiplied with 1 plus lambda into n plus pi plus r minus lambda n.
Both Levhari and Patinkin consider the services emanating from holding of real money balances as influencing individuals' disposable income. They show that when money is introduced as a consumer good in a single sector neoclassical growth model, the effect of inflation upon the degree of capital intensity in steady state equilibrium is ambiguous. They argue that it is the dropping of the assumption of a constant saving ratio rather than the different definition of disposable income, which yields qualitatively different results from those of the Tobin model. Money can also be considered as a producer's good. That is, it is held as it enables the economic unit in question to acquire or produce a larger quantity of commodities. Thus, money is being considered as an inventory. Here, the real value of money can be introduced into the production function. That is, y is a function of k, l and m upon p. This is linearly homogeneous in all variables. The relationship in this equation shows that the production is function of labor, L, physical capital K, as well as the real value of the working capital or the real money balances. But it is also assumed that money is an exogenous variable which is without any cost of production and administration. Actually, this theory by Levhari and Patinkin has been presented as dealing with the effects of rate of monetary expansion in the growth path of the system. However, the effects of monetary expansion differ in accordance with the use of this additionally created money. The government may use it for transfer payments, consumption, expenditures from the current budget on goods and services, and investment, with that is corresponding expenditure from the development budget. Even if the government does not itself carry out investment, it can affect the level of capital intensity in the economy by varying the proportion of its budget devoted to the consumption of goods and services as against transfer payments. It actually increases the physical consumption in an economy and reduces the savings and ratio of capital by transferring its expenditure from transfer payments to consumption of goods and services by government. Actually, in this case, the money transfers from the household sector, which has a propensity to consume less than 1, to the government, which has unitary marginal propensity to consume. Moreover, it has been assumed that money is issued by the government and is therefore an outside variety. But if we consider money as an inside generation of money through deposit creating activities of the banking sector or bonds loans market, it is held by this theory that the behavior of the individuals would not be affected by either the rate of change in prices or by the rate of expansion of the money supply. Hence, the system is neutral, especially in the second sense, which states that if nominal quantity of money is twice as high as before, then a price level will also be twice high, which will enable the system to return to equilibrium with all the real variables having the same values as before. To sum up the theory by Levhari and Patinkin, we can say that money can be used as a consumption good as well as the producer's good, and that it can play both these roles simultaneously. Hence, a general model of demand for money should analyze it both as a utility function and production function.
Next, we will discuss Johnson's view on money demand. H.G. Johnson in 1962 gave a complete analysis of classical, Keynesian, and the ISLM approach of determination of rate of interest. He proposed that the full Keynesian theory, in which the interest rate, income, saving, and investment, demand for money, and supply of money are mutually interdependent, can be represented by the ISLM curves. Johnson states that although the ISLM approach was originally developed by J.R. Hicks, which proved very useful standard tool for monetary theory, but it can also be adapted to take account of more general assumptions that Keynes made. For example, saving depend partly on income and that both demands for money demand on both income and the interest rates and investment partly on income and that both demand for money depend upon income and interest rate. It can be used to explain a number of important relationships to solve several monetary problems. Johnson suggested that this can be done by combining the Keynesian and Hicksian analysis.
Let us first focus on the given figure. The figure shows the supply curve of output XS, which is based on the assumption that the diminishing returns operate on variable factor, that is labor. This depicts the upward sloping nature of the supply curve. The curve YTS show different combinations of real output and prices, giving a downward sloping curve. The equilibrium price level and the output level are given by intersection of the supply curve with the real output curve. In figure, we can see real wage earned by labor, that is the marginal productivity of labor, and relation between real wages earned by labor and the quantity of labor employed, which is equal to its marginal product and hence shown by the MPL curve or the demand for labor curve. On the supply side, we can see the relation between the real wages earned and the labor supplied, that is the LS curve. Although the classicals say that the level of employment is determined by the intersection of demand for labor curve and the supply of labor curve. Yet, in the Keynesian theory, the levels of employment and real wages are determined by aggregate demand and the levels of output due to the technological relationship between them. If the real wage rate is OW0, the difference in actual employment and the labor supplies, that is L0LE, shows the involuntary unemployment. This indicates the additional output it could produce and hence reduce the prices. Johnson says that the chief argument of Keynesian theory relates to the question if underemployment equilibrium depends on the assumption of rigid wages. He says that the answer lies on effect of increase in money supply on wages and employment. Actually, the effect of a wage cut in the system is the same as the effect of an increase in money supply, as with fall in wages and prices, less money is required for transactions, more is available for speculative balances. With large quantities of money, there will be fall in rate of interest, leading to increase in investment and then employment. But the achievement of full employment depends upon the fact if the increase in money supply is adequate enough to push the economy towards full employment. There can be two cases in which increased money supply will not lead to full employment. These are, number one, the economy is already in liquidity trap. Number two, the economy is so interest elastic that at positive interest rates, investment does not increase or savings fall to a level consistent with full employment. Thus, full employment will not be achieved by monetary expansion or say a wage cut if savings from a full employment income would exceed investment at the lowest rate of interest. The money market will allow. Johnson further highlights certain controversies of viewing the Keynesian theory of employment as a theory of interest. These are, number one, Keynes himself initiated the debate if rate of interest is a real or monetary phenomenon. Johnson says that since Keynes' speculative demand for money is based on the relation between actual and expected rate of interest, the real forces ought to enter into liquidity preference in shape of profitability of investment. Number two, since in Keynesian theory, interest is a relation between the present and the future, expectations must influence the rate as determined in the market. Number three, another debate is related with the issue if rate of interest is determined by demand and supply of money or by the demand and supply of securities. To deal with this issue, we can divide the economy in three markets: the markets for output, cash, and the securities. The sum of excess demand in these three markets, that is XG, XM, and XS respectively, must be identically equal to 0. that is xg plus xm plus xs is equal to 0. Under full equilibrium in the economy, the rate of interest equates both the demand and supply of money and demand and supply of securities. But if there is disequilibrium in the goods market, we cannot say that the rate of interest is determined in either of the two markets, unless it is assumed that the remaining markets behave in such a way that the excess demand for output, that is excess of investment over savings, is financed by bond sales and loanable funds, so that when total demand for money in the economy is lumped together, it is just equal to the total supply of the same. On the other hand, in case of post-Keynesian version, Johnson says that in case of inducement to investment, the important development is the introduction of the relation between capital stock and output in the form of accelerator, or simply the capital output ratio as a determinant of investment decision. This permits the conversion of the static equilibrium of Keynesian system into cycles and growth models, in which the fixed capital investment can be considered as important determinant of income. The liquidity preference theory had been improved in a number of ways, particularly by extending the motives of holding money to asset holding as well. Johnson says that in monetary theory, the main contribution of Keynesian theory has been to emphasize the function of money as an asset alternative to other assets, and to break the quantity theory assumption that there is a direct connection between money quantity and aggregate demand. But this theory needs to be adapted to suit the non-depression conditions. Now let us summarize what we have learned in this module. Recognizing the importance of money in production, we can see that the approach of treating real money balances as an input in the production function highlights the central role played by money in production. But this is an inadequate approach, at least for two reasons. Firstly, money should not be considered as an input of the production function in the same way as the physical capital and labor. Money capital is a catalyst. It has no direct marginal product but operates only by influencing the way in which other factors are used. Including money in the production function precludes the analysis of how money affects the efficiency and organization of production. The theory by Levhari and Patinkin has dealt with the effects of the rate of monetary expansion in the growth path of the system. However, the effects of a monetary expansion differ in accordance with the use of this additionally created money. To sum up the theory by Levhari and Patinkin, we can say that money can be used as a consumption good as well as a producer good, and it can play both these roles simultaneously. Hence, a general model of demand for money should analyze it both as a utility function and production function. On the other hand, Johnson tried to show that the Keynesian theory of employment and output can easily be fitted into the framework, showing simultaneous equilibrium in money as well as the real market. He said that the monetarist success was transitory because its central problem, inflation, was inherently less socially important than unemployment. Johnson tried to incorporate the valid ideas of previous orthodoxy in the new framework. He argued that the success of a new idea in creating a revolution would depend upon the opportunity to escape from the intellectual authority of the past work by deploying novel analytic and empirical techniques.